Welcome you all to the lecture series on control systems. In the previous lecture, we have seen mechanical translational system. In that, we have seen various elements that are present and the force balance equation of each elements. In this lecture, let's have a look on a problem in order to determine the transfer function. Here, they have asked for two transfer functions. One is x1 of s divided by f of s and x2 of s divided by f of s. Here, f of s is the input and x2 of s is the output, and f of s is input and x1 of s is the output. So we know that transfer function Laplace transform of input output divided by Laplace transform of input with zero initial conditions. That's why I have mentioned here zero initial conditions. Okay, and while we are writing the differential equations, we need to consider nodes, because what are the elements that are connected to nodes? Based on that only we are going to write the differential equations. So we are considering mass elements as the nodes. So in this problem we have two masses m1 and m2. So we have two nodes 1 and 2. So we can write the force balance equation based on m1, that is various elements that are connected to mass m1. We can see here k1 is connected, b12 is connected, b1 is connected, and we have an applied force f of t, and we have to consider its own mass fm. And when we are coming to the node 2, that is based on m2, we have three elements b2, b12 and k2. Okay, here I have given the descriptions. Here there is a mistake. K2 is between M1 and the wall. Okay, it is not between M1 and M2. And B1 is between the ground and the M1. It is not between wall and M1. Okay, others are clearly mentioned. So what we are going to do is we are going to find x1 of s divided by f of s. Based on that, you can find x2 of s divided by f of s. Now let's look into the problem. So first of all, we have to draw the free body diagram, and then we have to write the force equation of node 1. Okay, as I mentioned earlier, mass m1 we are taking as node 1. So we have applied force. So we are mentioning the arrow mark away from m1, and other forces are the opposing force, where the arrow mark is being mentioned towards m1. So we have to consider the mass of its own body, because the body weight itself is a opposing force. When we are providing a force greater than the body weight, then only there will be a displacement. Okay, and we very well know that b1, b12 and k1 is being connected. Okay, so based on the force equation, we can write Fm1 is equal to m1 d square x1 divided by dt square. That is mainly based on F equal to ma. We know that equation. Okay, and the friction, that is dashpot, b1 f b1 is equal to b1 dx1 divided by dt, and b12 it is between mass m1 and m2, that is node 1 and node 2. So we are, when we are writing with respect to mass m1, we have to represent x1 minus x2. When we are writing with respect to mass m2, then we have to represent x2 minus x1. And we know that spring is directly proportional to displacement. So fk1 that is equal to k1 x1. Okay, now we are going to write the differential equation of node 1 based on Newton's second law of motion, where applied force is equal to opposing forces. So applied force here f of t, and opposing forces as we have mentioned in the diagram. Now we are going to substitute the equations which we have found here. Okay, based on, by substituting these equations, we will be getting f of t, and we are going to represent that part as equation number 1. Now we are going to apply Laplace transform. We are going to take Laplace transform. We are going to take Laplace transform. When we are taking Laplace transform for d square x divided by dt square, we have to represent the s square, and for d x divided by dt, we have to represent the s, and for um, uh, x of s, x of t, we can just represent x of s. Okay, instead of the t domain, we have to mention s domain here. And what we are going to do is we are going to rearrange the equation with respect to x1 of s, and we are with respect to x2 of x. So this equation we are going to take as equation number 2. Now we are going for um, node 2. We are going to draw the free body diagram and we are going to write the force equation. Okay, in node 2, as we know, m2 will be acting as the node 2. We are not having any applied force. We are just having the opposing forces, its own opposing force first, then b2, b12 is between node 1 and 2, and k2. Okay, for this we have to write the equation. So we know that mass is directly proportional to acceleration, and dashpot we are representing it with respect to velocity, and spring we are representing it with respect to displacement. Based on that, we can write the equations. Then, with respect to Newton's second law of motion, now we are going to write the differential equation. Okay, that is sum of applied force is equal to sum of opposing forces. So, sum of opposing forces, here we are not having any applied force, so we are mentioning it as 0. Now we are going to substitute all the equations which we have done earlier, and we are going to find the equation number 3. Same way we are going to take Laplace transform, and here we are going to write the equation. After taking Laplace transform, we are going to write with respect to x2 of s and x1 of s. Now we are going to find x1 of s divided by f of s. So we have to eliminate the x2 part. So from the above equation, that is from this equation, we have to find x2 of s. That simplification I have done here. Now, this fourth equation can be substituted in equation number 2. What is equation number 2? Here you can see equation number 2. We have x1 of s and x2 of s. If you are substituting x2 of s here, we will be eliminating x2 of s. So, we will be having x1 of s alone. So, by dividing x1 of s divided by f of s, we will be taking the transfer function. Okay. That part I have done here. I have first substituted x2 of s, you can see here, and now I am having x1 of s here and here, so I can take the common part of x1 of s. So finally I will be getting the transfer function x1 of s divided by f of s. In the same way, we can get the transfer function for x2 of s divided by f of s. So initially what we have to do is, by seeing the diagram, by seeing the system, we have to first of all note how many masses are there. Based on that, we will be getting the number of nodes. Based on number of nodes, we are going to draw the free body diagram for each node, and we are going to see how many elements are connected. That elements are being mentioned as the opposing forces, and we have to consider its own opposing force, and we have to see whether any applied force is there or not. So based on Newton's second law of motion, we are going to write opposing forces is equal to applied force. So sum of opposing forces is equal to sum of applied forces. Based on that, we are going to write the differential equation. Then we are going to convert that form to Laplace transform form, that is time domain to S domain. Then based on that, based on our requirement of transfer function, we are going to simplify the equation and we are going to write the final transfer function. Okay, I hope you understand this. If you have any doubt, you can put in the comments. Thank you.